Hello again. In today's video, we will be discussing the engineering subsystems of rotary wing unmanned aerial vehicles, as well as the specific units that are worked on. First, we can categorize the subsystems of the unmanned aerial vehicle as follows: our electronics section, our mechanical section, and our software section. In our electronics section, we have structures including the flight control board, motors, ESCs, and sensors. The key point is ensuring all parts are compatible. Our mechanical section consists of parts like the body, arms, landing gear, protective equipment, propeller holders, motors, and the base. The focus here is compatibility. When planning mechanical systems, ensure the body is large enough for electronics, but small enough to avoid enlarging arms and increasing costs. Additionally, ensure all parts move harmoniously. We need a compact body. Parts must move harmoniously. Integrate mission mechanism. This ensures that all our parts can move in harmony with each other. At the same time, we can also incorporate the mission mechanism into our mechanical discipline. The mission mechanism is built by engineers to carry out specific tasks. Mechanical part refers to both mechanical and electronic components. Our third discipline is the software discipline. In this area, we focus on programming the flight control board as well as the programming of the autonomous features. It's also the discipline where we can integrate relative software, trajectory processing software, or our AI software, programming the autonomous feature. It's also the discipline where we can integrate relative software, trajectory processing software, or our AI software. If we talk in detail about the mechanical parts of the drone is divided into subsystems in a mechanical sense. The first of these is our body. The body is the area where all our electronic equipment is connected and where the cables come together. It's the main part of our drone. And in the design of our body, we really need to pay close attention to the airflow. We need to place some magnetic equipment far apart from each other, and at the same time, the motors that connect to our body. We need to pay close attention to the strength of the points where the holders and arms connect. In the second part, we can talk about the arms. Our arms extend from the body and carry motors, making them most exposed to aerodynamic forces and thrust variability. They cannot endure wear and tear. Our landing gear increases the distance between the ground and the drone during landing. These are the parts that cannot be subjected to wear and tear. Our landing gear is designed to increase the distance between the ground and the drone during landing. It can vary in structure based on drone systems, but must absorb impact and minimize its transfer to the body. Additionally, it should withstand hard landings or angled landings due to wind, protecting the drone's body. But, especially, during landing, it needs to be able to absorb the impact and minimize the transfer of that impact to the body. Along with that, we expect our landing gear to not break during hard landings or when landing at an angle due to wind, thus protecting the parts of the body. The motor holders, where our arms connect, are located at the very top of our drone. These are the parts that need to be mounted very securely, as they are where the motor mounts and screws fit in. It's actually the mechanical part that contains the components that provide the main force, as it sits on top of the motors. In this mechanical part, we really need to be careful, especially during the screwing phase. Otherwise, our motors, which spin at a very high rate per minute, can fly out of their sockets while the propellers are attached, and that can actually lead to critical accidents. The body of our drone system and other mechanical parts can be made from different materials and substances. Especially nowadays, carbon fiber and plastic structures are being used a lot in drone technologies. Along with that, we can also encounter wooden or fiberglass structures. So, what are the differences between those made of plastic, carbon fiber, wood, or fiberglass? For example, I want you to think about it this way. One of the most critical and vulnerable points of drone systems is the landing gear. We expect our landing gear to be quite durable, and we can use our carbon fibers within this durability. Because carbon fiber is much stronger than plastic bodies or plastic materials. At the same time, plastic bodies can be integrated into areas where you think your body will sustain the least damage or where you believe it won't get damaged, as long as there are no falls or breaks. Because plastics are much cheaper than carbon fibers. You can use both carbon fiber and plastic parts at the same time in a drone. Because carbon fiber is a material that's quite difficult to shape, it's generally used in sheets or tubes. 3D printing cuts plastic costs. We can fix drone parts. At the same time, they are produced at a much lower cost due to the long-standing use of plastic injection technologies. If we can differentiate between the plastic parts and carbon fiber parts in our drone and measure the extent of their damage, we can not only carry out repairs, but also identify which of these parts might fail during the next flight while we're doing maintenance and repairs. As for our other two materials, wood or fiberglass, they are used much less frequently. We can also identify which of these parts might fail during the next flight while we're doing maintenance and repairs. Our other two materials, wood or fiberglass, are used much less frequently. The main reason for using wooden materials is primarily cost. Fiberglass, while having a higher cost, is more commonly found in products at the end of the production line because its strength is much greater, and while carbon fiber conducts electricity, fiberglass does not. To sum it up, plastic material is both cost-effective and quite lightweight because its strength is much greater, and while carbon fiber conducts electricity, fiberglass does not. To sum it up, plastic material is both cost-effective and quite lightweight. Along with that, there's durability. It's quite low, and it's much more likely that we'll experience a break. Carbon fiber materials are costly, but lightweight and strong. They've long been used in aerospace and aviation. Wooden structures, however, are much cheaper but more prone to breakage. Wooden structures, or wood-based constructions, are vehicles made at a much lower cost. The biggest disadvantage of wooden structures is that they are much more prone to breakage. At the same time, they have a much more flexible structure. Fiberglass materials are high-cost, high-strength materials that have the advantage of not conducting electricity, unlike carbon fibers. However, the challenges faced during the production phase are primarily due to technologies where costs are less of a concern. Like in the aerospace industry, we don't come across many uses outside of that. Focus on their ergonomic design. They must withstand airflow and protect electronics during crashes when fighting against airflow. At the same time, we expect it to be durable during any accidents or crashes and to protect the expensive electronic components inside. As a result, we see that in some areas of drone technology, plastic materials are used, while in others, carbon fibers are utilized. We've reached the end of this video. In this video, I talked about what mechanical components are made of and which materials are used. In our next videos, we will continue to explore rotary-winged manned vehicles.